Okay, now we're going to talk about what energy is. So energy is going to be abbreviated by capital E, and then its official metric unit is going to be called the joule, which is abbreviated with the J. So for the exam, can you give me like 4 different kinds of energy? And so here you have chemical energy, which we're not really going to talk about much in astronomy, but that might be a stick of dynamite exploding. Not going to do a whole lot with electrical energy, but you should be familiar with that energy in the form of electricity is what makes things operate in your house. We are going to do a lot with light. So electromagnetic radiation could be visible light, it could be radio waves, it could be infrared, and all those different kinds of light contains energy. Okay, we're not going to do a whole lot with thermal energy. That's again more, you do that more in chemistry, but we are going to do a lot with kinetic and potential energy, and then we are also going to do a lot with nuclear energy, nuclear fusion, and then nuclear fission. So these are all different ways of producing energy. So let's talk about kinetic energy. So this is a formula that you need to know. So E for energy, and then we put a K to indicate that it's kinetic energy, is going to be equal to 1/2 mv squared. So it's going to depend on the mass of the object and then the speed of the object. The faster it's moving, the more energy it's going to have. The bigger the object, the more energy it's going to have. So if I said that the speed doubles, what happens to the energy? Don't say that the energy doubles, okay, because it's v squared. So if it doubles, 2 squared is 4. So it'll have 4 times the amount of kinetic energy. So this explains why the thing that killed the dinosaurs, we think that it was an asteroid. That asteroid was very, very big, so it had a lot of kinetic energy. But the asteroid was also moving very, very fast. So both of those things, when you put it together, is the reason why that asteroid had a lot of kinetic energy. You also have rotational energy, but we're not concerned with that. So again, notice that the formula is very similar. It depends on how fast something is spinning. So that would be rotational kinetic energy. Okay, then you got potential energy, energy of position. So that the main kind of potential energy that I would want you to know for the exam is going to be gravitational potential energy. So that if I lift this thing up, I give it gravitational potential energy. It's a certain distance off the table. So if I release this, okay, you should be able to hear the energy being released when it hit the tabletop. So that it was potential energy, but then as it fell, it was being turned into kinetic energy. It started to move faster and faster. Okay, but another kind of energy is going to be electrical energy. And so if you got a charged particle, like a proton, and then another charged particle, like an electron, they are attracted to each other, just like this thing is attracted to the Earth. So there is energy in taking molecules and holding them at certain distances away from each other. That's chemical energy. And then the last picture there is nuclear energy. So that inside the nucleus, the pieces that make up the nucleus are certain distances away from each other, and there is a nuclear energy associated with the nucleus, which we'll get into later in the course. So for right now, just know about linear kinetic energy and then gravitational potential energy. Okay, conservation of energy, very, very important. So that the total energy E of a system is going to be equal to the sum of its kinetic energy plus its potential energy. So that if the total energy doesn't change, and if the kinetic energy gets smaller, the potential energy has to get bigger in order to compensate. If the potential energy gets smaller, the kinetic energy has to get bigger in order to compensate. So for example, the roller coaster. When the roller coaster is up here, it has a lot of potential energy. Then as it starts on its way down, it loses potential energy, but it goes faster. It gains kinetic energy. Planets will do the same thing. As a planet gets closer to the sun, it loses potential energy, but it gains kinetic energy. So it goes faster the closer it gets to the sun. So, sample question here. Okay, and then another thing that you need to know is power. So power is given by cursive P. And its official metric unit is going to be called the watt, a W. And so power is not, it's related to energy, but that's not the total thing. So it's energy and time. So the formula is it's the amount of energy per second that a device uses, or it could be the amount of energy per second that a device creates. So that an engine that is very powerful gives off a lot of energy every second. And so that's what we mean by power. This is going to be important because a star gives off a certain amount of energy per second. And another name for that is called luminosity. So L for luminosity is the amount of energy given off by a star per second. And you can see from there that our sun gives off a tremendous amount of energy every second. Okay, so that finishes up this lesson. So let's take a break, and when we come back, we will start in on our next lesson that you need to know for the Unit 1 lecture exam in astronomy.